doing? I want to try this technique of really trying to lecture for 10 or 15 minutes, knowing me it might be a little bit longer than that. So let's look at the first question. What is the energy at a distance r from the impact? Anybody have an answer for that? Anybody have problems with it? Nobody wants to answer either? Come on. Anybody?
Oh, I was gonna say we had a problem.
You had a problem with it? Okay.
Not like a problem.
Not a big problem?
It's supposed to be like, are we supposed to talk about like the energy relation of the problem or an actual
Yeah.
equation?
No. Well, you can kind of approximate the equation. I mean, it gets very complicated, believe it or not. But what I kind of wanted you to get out of this was the essence of what happens when waves spread. When you think about when you drop something in the water, you see the waves going out, right? In those concentric circles. What happens to the wave as it gets further away from the stone? When does it go up? No, it goes down. How does it go down? How does it go down? Is there anything that you can think of that would explain how the wave goes down? Well, let's say you have a circle here. This is 2D. Here. So let's say that I have a circle here, I have a source, an impact, and then I have a circle here. Now the energy here, E naught, is going to be spread equally along the circumference. So the energy per unit, this energy here is going to be the same as this energy here, which is going to be the same as this energy here. Everywhere along that circle, the energy is going to be the same. So if I have an initial amount of energy here, the energy at this point, we'll call this E1, what's that going to be in terms of E naught, roughly? What's the circle? The energy is going to be attenuated, where r is this distance right there, right? That's the circumference of the circle. We call that R1. Likewise, if I go a distance R2, and this is E2, that energy is going to have the same value per unit arc length around the circle. And that E2 is going to be E naught over 2 pi R2. So in general, in 2 dimensions, the energy is going to drop as the distance from the source, the receiver. Okay? So if I have a receiver out here, I have an ear out here, and I have an impact. I'm going to see an energy. So if we were to actually measure right here, and I said hello to all of you people along this line, right, we would know how the energy changes from the front to the back because of the length of the distance from B to U. Okay? So that's how energy works in 2 dimensions. What about 3 dimensions? What's the difference in 3 dimensions? It's not a circle, but it's a sphere. What's the surface area of a sphere? Volume is 4/3 pi r cubed. Surface area is 4 pi r next time at the beginning of class. One other point is what happens in one dimension? What if I only have a wave going along X? How does the energy drop? What? No, it does not drop. Basically stays constant because there's no spreading. Right? It's basically like along a tube, in theory, the wave just keeps going on forever and ever. That's the concept of the SOFAR channel. That's how we can basically transmit sound waves for long, long distances in the earth. Okay, see you next time.